please turn on your microphone from time to time as we conduct our discussion. So if you have any questions or clarifications, yan, pwede nyo namang i-type din dyan sa chat box. But please, from time to time, kindly turn on your microphone na lang. Okay? Sige, so for today, so ayan, hopefully you have attended our orientation. And based on our orientation, HEMA 2 is something about hemostasis. And part of hemostasis, big part of hemostasis will be your platelets, right? So for today, what we are going to do is discuss the production of platelets. Ayan, we call it as megakaryopoiesis. And at the same time, we'll talk about the structures and contents of your platelets, which makes them critical or special in hemostasis. Okay? So ito yung mga kailangan nating tapusin for today. So this will be our topic outline. So before we get into megakaryopoiesis, let's have first a short recall. Let's have a short review about about hematopoiesis. Diba? When we say hematopoiesis, it's the orderly production of blood cells. It's a controlled and regulated process of producing out your blood cells, right? And according to theories, in hematopoiesis, it all starts from an undifferentiated pluripotent hematopoietic stem cell. Yan, hopefully you can still recall it. And from that pluripotent hematopoietic stem cell, it will then give rise to two progenitor cells known as your myeloid and lymphoid stem cells. So obviously, from this lymphoid stem cell, this is where you will derive later on your lymphocytes. So it's either you have your B cell o kaya meron kayong T cell, right? Whereas, doon sa myeloid progenitor natin, this is where you will derive all other cells aside from your lymphocytes, right? The question is, these stem cells here, yung mga progenitor cell na yan, especially this myeloid progenitor, can produce all your mature functioning cells, but your stem cells, as what we say, needs to be committed or specific with only one, right? So question is, what should I do or what should I have for these stem cells to be committed in producing a specific cell line? What do I need to provide? What do I need to stimulate them to be committed in producing a specific cell? Anyone who can still remember it? Ano yung kailangan nila? Itong mga stem cell na yan, especially ang myeloid stem cell na yan, you will need to provide them with, turn on your mic para meron naman akong kausap. You need to provide them with, okay, good, with growth factors, right? Because these growth factors will allow the stem cells to be committed in producing a specific cell, right? So for example, ayan, so sa HEMA 1 ninyo, di ba, meron kayo EPO or erythropoietin that stimulates your stem cells for them to be committed in producing RBCs, right? You have their CSFs, colony stimulating factors, right? Ayan, kung maalala nyo, yung CSF gem, which helps your stem cells to be specific in producing granulocytes, erythrocytes, monocytes, and megakaryocytes. So basta tandaan, if you are after with the production of cells within your bone marrow, it will all begin from that pluripotential hematopoietic stem cell that will then give rise to a myeloid and lymphoid progenitor, which will be stimulated by different or various growth factors which allow them to be specific, okay, which allows them to be committed. So for today, our concern is more on your megakaryopoiesis. So you call it as such, you call it as megakaryopoiesis because what we want to produce are, obviously, are megakaryocytes, right? That's what we want to create, sir. That's what I want to produce, sir. Megakaryocytes. Kaya mo tinawag na megakaryopoiesis. O parang si erythropoiesis, di ba? Tinawag mo siyang erythropoiesis because what I want to produce at the end of the day are erythrocytes. You call it monopoiesis because what you want to produce are monocytes. So in this case, we have megakaryopoiesis that will help us to produce megakaryocytes. Ang tanong is, nasaan ngayon si platelet? Your end product here, your last stage here are megakaryocytes. So tanong is, nasaan ngayon yung platelets? Okay? Yan, dinaanan lang natin ng konti yan sa HEMA 1. But if you may recall it, platelets, remember, are just cytoplasmic fragments of megakaryocytes. Okay? Meaning to say, if this will be my megakaryocyte, there will be platelets on its cytoplasm. So if you'll analyze it, you will not come up with platelets without producing your megakaryocytes, right? You won't have any of these platelets without your megakaryocytes. So what your megakaryocytes will do later on is just shed them out. O parang i-release lang niya yung platelets na yan. So at the end of the day, if you will analyze it, you need to produce first your megakaryocytes so you can then come up with your platelets. That's why, if you will go over with books, ayan, sa kay Rodax for example, if you go with platelet production, you will always need to deal with megakaryopoiesis. Okay? And to make these myeloid stem cells to be committed in producing your megakaryocytes, ayan, as what we have mentioned a while ago, kailangan natin ng growth factor. So if sa red cell, meron kang erythropoietin, in megakaryopoiesis, in producing out your platelets, you have now your thrombopoietin. As well as yung binanggit natin kanina, CSF-MEG, colony stimulating factor, excuse me, megakaryocytes. Okay? Are we clear so far? It's just lang for a while, ha? Ayan, okay, going back. So, are we clear so far?
Yes po.
Maliwanag ba? Okay, sige. So, going back. So, if you will go with the stages in megakaryopoiesis, so from your, jump na natin ha, huwag na tayong bumalik sa pluripotential. Punta na tayo dun sa myeloid stem cell. Okay? So, from these stem cells, once they are stimulated by these growth factors that we have, it will then give you certain stages. Okay? So, meron mga sunod-sunod na stage. So, parang habang nagmamature siya, definitely, you will have various stages. So, stage 1, stage 2, and so on and so forth. Okay? So, in megakaryopoiesis, we have these things called, after the myeloid stem cell, we have this thing called lineages, lineage progenitors. Okay? The problem is, if you will examine these progenitors, anong ibig sabihin uli nitong BFU at saka CFU? Kung maalala, BFU is burst forming unit and CFU is colony forming unit. Okay? Ang problem lang dito with these progenitors is that if you will examine them, they all look the same. Okay? Your red cells, for example, sa RBC natin, meron din tayong BFUs at saka CFUs. So if you will go over with its characteristics, pare-pareho lang sila ng itsura. Okay? So if you will just examine them morphologically, you cannot distinguish which is which. So theoretically, if it's because of thrombopoietin, for example, the burst-forming unit or colony-forming unit that you have is then associated with megakaryocytes. Okay? Theoretically, ha? Theoretically. Pero morphologically, if I will examine, let's say, meron ditong BFU meg and then meron ditong BFU erythroid. If I will just examine them morphologically, hindi ko malalaman kung sino si meg or kung sino si erythroid. Okay? When you say morphologically, I'm examining it. For example, sa microscope, ina-examine ko siya. I will not know. Is it a megakaryocyte or is it a erythroid? I don't know. Okay? But theoretically, if you will base it on theories, if you will base it on books, on science, using thrombopoietin, the BFU that you have is what you call as MEG or BFU megakaryocyte. Okay? So with these lineage progenitors, maliwanag ba yon? Is that clear? Okay. So with these progenitors, the first two that you have, BFU meg and CFU meg, do not forget these two are capable of the regular mitosis. Okay, mitosis. That is cell division. And in regular mitosis, you start from a mother cell that gives you two identical daughter cells. Right? Parehong-pareho sila. So, mula sa isang cell, magiging dalawa. At pag nag-mitosis pa uli yan, madadagdagan uli pa ng dalawa and so on and so forth. Okay? So that's why these first two progenitors here, BFU meg and CFU meg, are then part of your so-called proliferative phase. Proliferative meaning to say, you want to increase the number of your progenitors. Nagpaparami sila. They undergo that regular or usual mitosis that we know because you want to increase the number of progenitors. So you will have a pool. Parang meron kang storage. Meron kang backup. Okay? But when you reach this stage, yan, pag nawala yung zoom, again, balik lang kayo When you reach this stage, the light density colony forming unit, MEG, LD is light density, you will stop from having mitosis. Hindi na siya magdi-divide ng regular mitosis. Instead, when you reach this stage, your stage will now undergo a special type of division known as endomitosis. Okay? Pag sinabi nating endomitosis, it's like your nucleus will still divide. So there will still be DNA replication. Your cytoplasm will still mature, but they will not divide. There won't be any telophase. Kung familiar pa kayo sa mga phases of mitosis. Diba, in mitosis, you have prophase, metaphase, anaphase, telophase. Right? Pag sinabi nating telophase, that is when your cytoplasm totally separates. So from isa, diba, sa mitosis, nagiging dalawa na. In endomitosis, you don't have such thing. You don't have telophase, you don't have cytokinesis. In endomitosis, your DNA will continuously replicate, your cytoplasm will continuously mature, but they will not divide. So when you reach this stage sa light density colony forming unit megakaryocyte, endomitosis will occur and it will be something like this. For example, para alam natin kung ano yung endomitosis. You have a single nucleus, for example. So if your cell will undergo endomitosis, the cytoplasm will continuously mature, but the nucleus will then divide. Parami sila ngayon ng parami. Pero you started from one cell and you will end up still with a single cell. But this time around with multiple nuclei inside. So as the cell mature in endomitosis, having such this process here, as the cell mature, imagine niyo, ano kaya mangyayari sa size ng cell natin? Lalaki or liliit? Anong mangyayari sa cell natin? Lalaki ba sila?
Larger.
Or paliit sila ng paliit? It will then become larger and larger. Right? Because your cytoplasm continuously mature and to accommodate the increasing number of your nucleus, you need to expand. Right? And remember, sabi natin kanina, sir, platelets are just cytoplasmic fragments of megakaryocytes. Right? So the more your cell, the more the stage has more nucleus, the more your cell will expand. As they expand and expand, the more chances of platelets being released out from your cytoplasm. And that cell can contain up to 32 nuclei inside. Imagine, parami sila ng parami. And that's the reason on why mature megakaryocytes are said to be the largest cell in your bone marrow. Because as compared with erythropoiesis, for example, sa erythropoiesis, as the cell mature, paliit sila ng paliit. Right? Diba? From pronormoblast, magiging basophilic normoblast, hanggang maging RBC, they become smaller and smaller. But on this case, as the cell mature, they become larger and larger. That's why a mature megakaryocyte is said to be the largest cell, largest hematopoietic cell in your bone marrow. And it is because of your endomitosis. And endomitosis, remember, is unique among megakaryocytes. Is unique in megakaryopoiesis. You'll not see endomitosis in any other cell types. Wala yan sa RBC, wala yan sa WBC. Okay? It's only within your megakaryopoiesis. Sila lang yung palaki ng palaki. 'Di ba? Even sa WBC, 'di ba, nagmamitosis din sila, so paliit naman sila ng paliit. But on this case, in endomitosis, they become larger and larger. So expect that in megakaryopoiesis, as the cell mature, expect them to be larger. And since the nucleus is dividing, syempre, habang nagdi-divide yung nucleus, paliit sila ng paliit. So that's why the NC ratio or the nuclear cytoplasmic ratio then decreases as your cell continuously mature. Okay? And usually, from the earliest recognizable stage in megakaryopoiesis until it goes to megakaryocyte, it will take you roughly about 5 to 7 days. So once you reach this stage, jump natin ha, once you reach this stage, yung MK1 na yan, until it goes to MK3, it will take you about 5 to 7 days. Kasi that MK3 is the one that will then be capable of releasing out your platelets. Okay? So ulitin natin. So from BFU meg and CFU meg, they will undergo the regular mitosis, so you can have a pool of progenitors. So para meron kang stock, di ba? Meron kang reserba ng mga progenitor cells. But once you reach this light density colony forming unit, you will now stop the regular mitosis and enter your special cell division called as endomitosis. And from this point up to the last one, you are now on the phase called terminal differentiation phase. Ano kanina yung phase ng BFU-MEG at saka ng CFU-MEG? How do you call that?
Proliferative.
Proliferative. Ibig sabihin, nagpaparami sila. Right? But on this case, look at the term. Terminal. Di ba? Pag sinabi natin terminal, papunta ka na dun sa dulo. Right? Terminal differentiation, meaning to say, when you reach the final stage, that is the time when your platelets will now be released. Okay? So, in microscopy, if you will observe these stages under the microscope, since this is still a CFU, hindi mo siya kayang identify agad-agad, right? In hematopoiesis, you always start with the earliest recognizable stage. And the earliest recognizable stage in megakaryopoiesis is what we call as MK1, followed by MK2, followed by MK3. So the other terms we use for that would be, megakaryoblast for MK1, promegakaryocyte for MK2, and megakaryocyte for MK3. Okay? So the earliest recognizable stage in megakaryopoiesis would be your MK1 or megakaryoblast. Okay? It's a bit difficult to distinguish megakaryoblast from other blasts in your bone marrow, but one distinguishing factor of megakaryoblast as compared to other blasts in the marrow is that your megakaryoblast has these blebs. O meron siyang mga tags, cytoplasmic protrusions or plasma membrane blebs, so you can easily distinguish this megakaryoblast from other blasts in your bone marrow. Okay? And one important thing that you need to take note of in megakaryopoiesis is the presence of your so-called DMS. DMS or demarcating membrane system. As to theories, yung DMS na yan is the individual network system of platelets. In short, you will not form platelets without your DMS. Okay? Ayun lang yun. So, ang tanong is, sir, yung tatlo ba na yan, sir,